So in this demo, we're going to look at moments of inertia. So here's a disk, and this is a hoop. They have different moments of inertia. So the moment of inertia of a disk is 1/2 mr squared. Of a hoop, it's mr squared. There's no half in front. So you can see they're about the same size. Their radii are the same. They're about the same mass. So what we're going to do is try to roll them down this incline and see what happens. Which one of these gets down first? So let's try to start them off approximately at the same place and let go. So you might want to take a second to think about which of these do you think is going to come down the ramp first. So let's try this out. So you can see that this disk came down first, and it has to do with its moment of inertia. So this has a smaller moment of inertia than this hoop. So what that means is that as these are rolling down, the one that has a larger moment of inertia has a larger resistance to rotate. That's what it means to have a larger moment of inertia. This one has a smaller moment of inertia, so it has an easier time to roll and come down the ramp before the other one does. So again, the radius, about the same for each one, the mass is about the same, but it's a matter of how that mass is distributed that matters. In this case, you can see that all of its mass essentially is concentrated at its edges, where in this case, it's more distributed. So as it rotates about this point, it has less mass that's too far away from its rotational axis, as opposed to this one, where all of its mass is far away from its rotational axis. So this one has a larger moment of inertia. It finds it harder to roll down the ramp, and that's why this disk comes down first. So this is a demo of different moments of inertia.